So, for example, with ethanol, E85, 80% ethanol, then these are the things that definitely need to be changed. The engine control unit or electronic control unit, fuel injectors, etc. So this is part of the consideration on selecting a alternate fuel. One thing is microbial contamination is an important factor, and then material incompatibility, which is what the automotive design engineers will take care of. For this, you can think of, say, taking some canola oil and setting it on your kitchen counter for 3 months and then see how much mold and how much deterioration it is. And an alternate fuel likely will have about the same difficulty. So here we're looking at serious contenders. For diesel substitute, vegetable oils are important. Gasoline and diesel, the alcohols are very important. Petroleum gas, which is a mixture of propane, natural gas, largely methane. This is what PG&E delivers to your house or your dormitory. And then hydrogen has the allure of the future, and then biogas from landfills, etc. And I show this fine watch to illustrate the point that the fuel injectors in a modern car are very precision. And so for this watch, there are people willing to pay $9,300. And so if each fuel injection was the same price on a V6, you'd be priced out of the market. But in any event, modern fuel injection uses precision, and it's possible that if the fuel is not correct, contamination from the fuel can cause early failure. Now we look at the chemistry of alternate fuels, and I have to apologize to the chemists that this particular version of the chemical periodic table is not exactly correct. There's been some liberties taken with it, but the reason that it's in that form is it does illustrate what I want to talk about, but also it's easy to type. And so each one of these X's here represents an element, and 111 elements are currently known, of which if you remove hydrogen and carbon, you have 109 elements, which make up the branch of chemistry known as inorganic chemistry. And over here is the branch organic chemistry. And the amazing thing is, out of this branch, there's nothing there that's a fuel. There's nothing there that qualifies as an alternate fuel. You might say, well, I'm wrong on that because hydrogen is considered not a fuel, it's a carrier of energy. So the focus is over on the hydrocarbons, organic chemistry. And then we could just say, well, we got an organic car, inorganic. And the fuel cell vehicle with hydrogen would be the only one. And then I failed to point out, but in that chart, just below carbon is silicon. And carbon and silicon are kind of in the middle of the chemical periodic table. And it's evolved that on Earth, carbon and hydrogen are the atoms of life. And so you could conceive of one of these distant planets that the astronomers are looking for now. The silicon and hydrogen might be the atoms of local life there, and you'd have strange things like blue leaves on trees. And we're going to talk some about petroleum. This is the chemical formula for petroleum. N is, of course, the number of carbon. The hydrogen are 2N plus 2, and then we show an oil well just to get in the spirit of things. And the even more spirit here is an old gusher from 1922. And here are the number of carbon atoms. You take crude oil, and it's got molecules from 2 carbon atoms on over to 40 carbon atoms. But when that's refined to diesel, then it ranges from 8 to 25, 4 to 12 for gasoline. But the amazing thing is the alternate fuels, the most under development now, biodiesel is either 18 carbons or 19 carbons. And that's dictated, of course, from the chemical structure of the vegetable oil. And ethanol, of course, is pure. It's got two carbon atoms. And here's a flask of medium sweet crude. And here's another chart, which across the top we got percent. And then up here is a formula which gives you this percent. And the percentage is the amount of carbon dioxide in the combustion gases. And the rest with hydrocarbon is water. And so with hydrogen, since there's no carbon, you get 0 carbon dioxide. Natural gas is 33, petroleum is about a half, but over on the far right, coal is largely 100% carbon. It does have some hydrogen. However, when you burn coal, then almost 100% of the exhaust gas is carbon dioxide, which makes coal kind of a dirty source of energy. Over along the bottom, we have gas, the various states of matter, and liquid is by far the most convenient. You can pack a lot of energy density into a gas tank, and so the common gasoline and diesel are liquid. However, hydrogen and natural gas, the main way that they're used today is by compression. And so the Honda Clarity and the Chevrolet Equinox fuel cell, they use like 5,000 PSI hydrogen tanks. The could be liquefied, but that's not the technology in an automobile. And then there are such things as oil shale and tar sands as another source of petroleum. And this happens to be a picture of some oil sands from Alberta. And that's under very active development, a lot of work going on in Alberta. So if you're unemployed in the United States, immigrate to Canada and get a job in the tar or the oils. The hydrogen chicken and egg problem, the automobile companies do not want to make cars that use hydrogen if there aren't any hydrogen pumps. And the energy companies don't want to make pumps if there aren't any cars to use it. And one of the interesting aspects is that for pressurized, that's the price of one pump. So it's very expensive to change a service station over to hydrogen. You can, of course, make hydrogen from electrolysis. You get the hydrogen, the oxygen, feed it into a fuel cell. You get the energy out to drive your automobile. This energy in can be clean energy, wind, solar, and then you can recycle the water. And then I show you here Spaceship Enterprise, and in the universe outside of our planet Earth, the most dominant molecule is the H2, hydrogen, just in the form we'd like to use it. So we're going to issue orders to Captain Kirk to go out in the universe and scoop up a lot of hydrogen and bring it home. Biology of alternate fuels, and this is a focus on biomass. This is a different way perhaps to show the carbon dioxide cycle, and this line represents kind of a ground state, and then as you go up in energy, then you get a higher energy and the line is up higher. And so plants in particular can take these three things, combine them through photosynthesis to create a biomass. But there needs to be refining for most applications, like if you want to use it in your car. And then the energy consumer is you, and you return back to carbon dioxide and water. There's a big intersection in the alternate fuels between chemistry and biology, and there are conferences where you have bio-inspired chemistry for energy. That is, you look to Mother Nature on how Mother Nature does it. There's a buzzword going around now